Welcome to the answer key explanation video for geometry, the chapter 4 test review. Now again, as we go through this, please make sure first that you have already turned in your copy of the review attempting each problem. And then feel free as we go through the video to make changes, add notes, leave yourself some extra information that will help you on the upcoming test. So the first thing you want to keep in mind for numbers 1 and 2, you would want to use the distance formula, and it's also easier to plot these points on a graph just to help you visualize if any of the sides are the same length. So for numbers 1 and 2, I'm going to scroll down to my third page here where I did the work for those. So you can see for number 1, once it was plotted, the distance of AC, we can just count, is 2 units. For AB and BC, we're going to use the distance formula. So using the points for AB, we end up with AB's distance being the square root of 10. And for BC, we also end up with the square root of 10. So sides AB and BC are congruent, making this an isosceles triangle. At least two sides are congruent. Then in number 2, again, plotting triangle XYW. And once it's plotted, we can see that segment XY is 4 units, XW is 3 units, and we just need to figure out the length of YW or WY. So again, we're going to use the 2 points W and Y to get our X and Y coordinates. Put those into the distance formula. We end up with the square root of 25, which is 5 units. So in this case, all 3 sides are different lengths, making it a scalene triangle. All right, now back up. Number 3. So looking at number 3, we need to keep in mind our different properties, postulates, theorems, along with info that they gave us. So to find the measures of X and Y, we know in X they're looking for degrees. And I know this triangle that the 75X and this missing angle are part of is an isosceles triangle because these 2 sides are congruent. So if these 2 sides are congruent, I can use the base angle theorem. If this side or this angle is 75, this angle is also 75 because the 2 angles opposite the congruent sides are congruent. And then we know 75 and 75 leaves us with 30 degrees missing of the 180 because 75 and 75 is 150. So this angle has to be 30. Then the 30 and Y equal the right angle here. So 90 degrees minus 30 gives me the measure of Y at 60 degrees. So X was 75, Y was 60. Now let's move into number 4. In number 4, we know this triangle right here is an equilateral triangle because all 3 sides are congruent. So I know this angle, and this angle are each 60 degrees. The 3 angles in equilaterals are always 60. Then I can use that information to first figure out what X is going to be. Because X plus the 60 plus the 40 makes a straight line. Straight lines measure 180 degrees. So 180 minus the 60 and the 40 here leaves me with X being 80 degrees. Then I know this line here is parallel to this line here. Meaning this angle here that's 60 and this angle here that's Y are alternate interior angles. Alternate interior angles between 2 parallel lines are always congruent. So x and y, or x we already established was 80, y is 60 to equal this angle here. Now let's go down to 5. On 5, we know x and y are both going to be 60. How do we know that? Well, the 60 here is a vertical angle to x, and vertical angles are always congruent. So I know that the 60 here equals the 60 here. Then I know one of the angles in the triangle with y is 70. I can figure out this angle right here that's missing because the 60, the 70, and the blank angle make a straight line, or 180. So 180 minus the 130 from the 60 and 70 tells me this missing angle right here is 50. So then the 50 and the 70 is 120. So what's missing out of the 180 for y? 180 minus 120 gives me y being 60 degrees. And then we get into number 6. In 6, again, we're looking for x and y. Well, y is the one I'm going to find first because in the triangle with y, this angle's 20, and this angle right here would be 90 or a right angle because it's adjacent to a right angle. So I have 90 and 20, or 110 degrees. So 180 minus the 110 means y is 70 degrees. Now, to figure out x, which is 40. If I know this side is congruent to this side, I know their opposite angles are also congruent, meaning the x and this missing angle down here are congruent. So I can find this missing piece by taking 180 minus the 50 and the 90, giving me 40 degrees. If this right here is 40, base angle theorem, two congruent sides, means x is also 40 degrees. So on numbers 3, 4, 5, and 6, it's mixing together a lot of our different congruence rules and different types of angle rules. But what you want to remember is triangles always add to 180. Now in numbers 7 and 8, we're using congruent parts to figure out the measures of x and y. So in number 7, we have two equilateral triangles. I know all three sides on this one are congruent and this one, and because they all have one hash mark, they're equal to each other. So in number 7, I can find x by setting it up as 9x equals 45. 9x equals 45 means x would equal 5. 45 divided by 9 is 5. Once I have that 5, I can plug that back in to this equation where I know 3y plus 3x also equals 45. And the math for that is right down here on this third page. So then I'm going to take this x equals 5, put it back into this original. So 3y plus 15 equals 45. Subtract the 15, 3y equals 30, divide by 3, and y equals 10. Now in number 8, we need to go back to Algebra 1 and think about how do we solve when we have two variables in two equations. Well, if I look at this for number 8, I know that 10x plus 6y equals 38 degrees. Then I know this one here is 52 degrees because 90 and 38, what's missing is this angle. So I know the 20x plus 4y equals that piece there. So my setups for number 8 would be the 10x plus 6y equals 38 to start, and the 20x plus 4y equals 52. Now what I want to do is to multiply one of these two top equations by a number to make one of the variables cancel when I add the two equations. So I'm going to take the 10x plus 6y equals 38, and multiply everything by -2. So that becomes negative 20x minus 12y equals, and that should be a negative 76. So put a negative in front of that 76. So then when I add my two equations, the original one is 20x plus 4y equals 52. And my other one is now negative 20x minus 12y equals negative 76. So when I add those together, the x's cancel, and I have negative 8y equals negative 24. Divide by the negative 8, and y would equal 3. Now to get my value of x, I can take this 3 and put it back in for y in either of my original equations to solve for x. And when you do that, you will see that x comes out to be 2. Now let's move down to 9 and 10. 9 and 10 asks, is it possible to prove the triangles are congruent? If so, state which postulate or theorem you would use. So in number 9, they already told us angle B congruent to D, side AD congruent to BC. We also know these two triangles share side BD. So BD is congruent to itself. That gives me side, angle side, and side, angle side for both triangles. So yes, they're congruent by side, angle, side. And then in 10, I notice right away these are right triangles. So I'm looking for the idea of hypotenuse and leg. They gave us the bottom legs are congruent. The hypotenuses are congruent. So yes, these triangles are congruent by hypotenuse leg. Then we get to 11 to 14, asking, is it possible to prove that a triangle ABC is congruent to DEF using the given info? If so, state the postulate or theorem that you would use. And if you're struggling to figure out 11 to 14, I would just draw yourself two triangles, ABC and DEF, and label the information as you go. That can help you get a visual of what's going on. So in 11, yes, those two triangles based on the info could be congruent because of side, side, side. In 12, even though they give us two sides and an angle, they don't match up for angle, or side, angle, side. So that would be a no. 13, they just gave us three sets of angles. We do not have an angle, angle, angle congruence postulate, so 13 would be no. And in 14, when we label what they gave us, that gives us angle, angle, side. So yes, 14 would be angle, angle, side. And again, I'd draw yourself images there, label the parts you know, and see if one of the triangle relationships works. Now in 15 and 16, they give us translations, and they want us to sketch the original figure. So in this case, they're giving us the image, the final picture, and the translation. They want us to go back to the original. So in this case, if they gave us this triangle right here at 2, 4, 4, 3, and 3, 0. The original translation tells us to go right 5 because x plus 5 and y minus 1. So that would be right 5, down 1. But because we're going back to the original, we're doing the opposites. So we're going to move each point left 5 and up 1. So your new triangle, the original, would be right here at negative 3, 5, negative 2, 1, and negative 1, 4. And then in 16, the original translation is subtracting 5, meaning left 5. So when we're going reverse, we're going to go right 5. And the original translation was up 2. So going back to the original, we're going to go down 2. So we're going to take each point and move it right 5, down 2. So this figure here gets moved right 5 and down 2. So it should end up right here with these as your new coordinates. 17 and 18 are just asking, is the figure a rotation? If so, give the angle and the direction of the rotation. So in 17, they're asking, is figure A a rotation of B? No, it would be a reflection. It just flipped. So no, it did not spin or rotate. In 18, triangle B right here in the dashed lines to triangle A. In this case, that triangle rotated 90 degrees clockwise to become A. So from B to A, it spun 90 degrees in a clockwise direction. And then our last problem on here, number 19, says the stencil below on the left creates the design shown on the right. So this is the original stencil. This is the final design. They want us to describe how to reflect the stencil to move it from A to C. So how do we get from A down to C? So the first thing you do is you would take A and reflect it over the x-axis. That gives us B. Then reflect B over the y-axis to give us C. Or you could go vice versa. A reflected over the y gives us D. D reflected over the x gives us C. Either answer would work. So if you're confused at all on the review, please make sure in between now and the test that you come see me and I can walk you through any of the questions you weren't sure how to complete.